this video, you'll learn about conditional probability in the context of an example. The conditional probability is the probability of one thing happening given that something else happens. For example, pretend you're playing a game that involves a scratch card that will reveal 2 diamonds, each of which can either be a gold, silver, or black diamond. If both diamonds are gold, you win $100,000. So there are 2 events that you want to occur, that the first diamond is gold and that the second diamond is gold. We can symbolize these events any way we want. So let's go with 1 sub G and 2 sub G. So the first diamond's gold and the second diamond's gold. We can also visualize this concept using a Venn diagram. This circle represents the probability that the first diamond is gold. So this is the event that 1 sub G occurs. This circle represents the probability that 2 sub G occurs. So you could have events in here where the first diamond is gold, but the second diamond's not. Or events in here where the first diamond's not gold, but the second diamond is. But ideally, you want something at the intersection of these 2 sets, which is that both of them are gold. Outside of these sets would be combinations where neither of them are gold. So you could get 2 silver diamonds, or you could get 2 black diamonds, or your first diamond could be black and your second one silver, or your first one silver and your second one black. So you see there are 9 possible options. Now let's say that if the first diamond is gold, you have a 20% chance of the second diamond being gold. We can write this idea in this way. The probability that the second diamond is gold, given that the first diamond is gold, is 20%, or 0.2. Now suppose there are thousands of these scratch cards, but you know that there are only 15 cards in which the first diamond is gold. On how many scratch cards are both diamonds gold? Try pausing the video and figuring this out. It's okay if this was tricky. It's a simple concept, but communicated using complex probability terms and notation. It's important to understand this language, and you will by the end of this video. So let's answer this question. You heard earlier that the probability of the second diamond being gold, given that the first diamond is gold, is 0.2. This means that of the 15 cards whose first diamond is gold, the probability of the second diamond being gold is 0.2. In other words, 20% of these 15 cards will have 2 gold diamonds. Let's use the Venn diagram. You know there are 15 cards in which the first diamond is gold. And there's a 20% chance of getting something in this intersection, given that you got something in this set. So the number of scratch cards with 2 gold diamonds divided by the total number of scratch cards in which the first diamond is gold is this probability. So we don't know how many scratch cards have both gold diamonds, but we know that there are 15 total scratch cards in which the first diamond is gold. From this equation, we can solve for n, which is the number of elements in this intersection. That means there are 12 cards in which just the first diamond is gold and the second is not. Now let's say there are 1,000 cards out here that have no gold diamonds, and there are 17 cards in which the second diamond is gold. We can mathematically test whether or not these 2 events are independent of one another. Independence means that the probability of one event does not depend on whether or not the other event occurs. If the probability of one event multiplied by the probability of the other event is equal to the probability of the intersection, the 2 events are independent. Let's calculate this. The probability that the first diamond is gold is the number of cards where the first diamond is gold, 12 plus 3, divided by the total number of cards, 12 plus 3 plus 17 plus 1,000. The probability that the second diamond is gold would be then 3 plus 17 divided by the total number of cards, 12 plus 3 plus 17 plus 1,000. If the 2 events are independent, these probabilities multiplied together should equal the probability of the intersection, which is 3, since there are 3 in the intersection, divided by the total number of cards. So if we multiply these probabilities together, this does not equal 3 divided by 1,032. Therefore, the fact that one of the diamonds is gold will impact whether or not the other diamond is gold, and these two events are not independent. Great work!